So I am Dr. V. Hindumati, Associate Professor, ECE Department. So in this video, we will see the digital electronics subject contents. So the digital electronics subject code is IT301 PC and it is in second year BTech first semester subject, belongs to CSC branch. So this is the syllabus of digital electronics. If you once go through this syllabus consists 5 units. Unit 1 is with Boolean algebra and logic gates, and Unit 2 is gate level minimization. Unit 3 is combinational logic. Unit 4 is sequential logic, and Unit 5 deals with memories and asynchronous sequential logic. So for this subject, we are having 6 COs. What is digital electronics? So digital electronics is nothing but it uses binary logic to study digital systems, and it is the foundation course for computers and embedded systems. So these digital electronics used in processors, communication systems, automation, robotics, and AI hardware. What is the importance of digital electronics? This is the basis of modern electronics and essential for hardware and system design. And this is the core subject for IT, CSC, and ECE students also. So what are the course objectives? So the course objectives belongs to digital electronics subject is understand digital logic fundamentals, learn Boolean algebra and simplification techniques, and next digital design combinational and sequential circuits, study memories and programmable logic devices, and finally analyze asynchronous sequential circuits. Next come to the course outcomes. So course outcome is nothing but after completing what student can do. So once completing this digital electronics course, the student will be able to apply number systems and binary codes, minimize Boolean expressions, design combinational circuits, design counters and shift registers, understand memories and PLDs, analyze asynchronous sequential circuits. So what are the applications of digital electronics? So in real world applications, everywhere we are using digital electronics, computers and laptops, smartphones, digital watches, robotic systems, communication devices, traffic control systems, medical electronics, embedded systems. These are some of the examples are only, many more are there. So coming to the syllabus, unit 1 deals with Boolean algebra and logic gates. So in this unit, topics covered are number systems, binary arithmetic, Boolean algebra, logic gates, canonical forms, binary codes and registers, basic logic gates. So we are having different logic gates: AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR and XNOR gates. So these are the basic digital logic gates. So to design any logic circuits, we are using these are the gates. So number systems. So here we are having different number systems. Students will learn different number systems and number based conversions also, and Boolean algebra logic gates. Without logic gate, we cannot design any logic circuit. So coming to unit 2, gate level minimization. So in these topics are covered K-maps or Karnaugh maps, SOP and POS simplification, using NAND and NOR implementation, don't care conditions, XOR function implementation, and so the advantage, if you read this unit, gate level minimization, advantages are reduced hardware cost, improved speed, and simplifies circuit design. So these are examples of K-maps used in the syllabus. Okay, so K-maps used for simplifying SOP expression as well as POS expression. So we are having 2 variable, 3 variable, and 4 variable. So next level is 5 variable also. So coming to unit 3, combinational logic circuits. The topics covered in combinational logic circuits are adders and subtractors, multipliers, comparators, encoders and decoders, multiplexers. So these are the just some examples of topics covered. So this is half adder which will add 2 input bits and gives 2 output sum and carry. So once you learn the gates, so these are the 2 logic gates. Once you learn combinational logic circuit, you can design any circuit, combinational logic circuit. This is example for half adder. Similarly, you will learn full adder, half subtractor, full subtractor also. And coming to this figure, this is a comparator circuit. You can observe outputs is A less than B, A equal to B, and A greater than B. So depending on the given inputs, you will get prospective output. So for this is the design, and this is a 2-bit comparator. And one more example you can observe here, this is a multiplexer circuit. So depending on the given selection input lines, at a time only one input will be selected and that will be propagated at the output side. In detail, you will learn in the subject. So the key concept behind this combinational logic circuit is, in this logic circuit, output depends only on present inputs. So generally used common combination logic circuits are half adder, full adder, multiplexer, decoder, encoder, comparator. These are the topics covered in our syllabus. And what are the applications of these combinational logic circuits? Once you read combinational logic circuits, you can design ALU circuit, data selection, address decoding, and arithmetic operations. Now coming to unit number 4, there is a sequential logic. So in sequential logic syllabus, topics covered are flip-flops, registers, shift registers, ripple counters, synchronous counters, state reduction techniques. And the key concept in sequential logic is output depends on present input and previous state. Whereas in combinational, output depends only on present input. This is the basic difference between combinational and sequential. And basically, digital circuits are classified into either combinational or sequential. So these are the some examples given. Flip-flops. First topic is flip-flop. This is the basic one for sequential logic. So without flip-flop, there is no sequential logic. So there are 4 types of flip-flops are there: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. Okay, flip-flop is 1 bit storage element. And coming to here, registers. So register can store more than 1 bit, and simply register is a combination of flip-flops. So we are having 4 types of shift registers. SISO, serial in, serial out, serial in, parallel out, parallel in, parallel out, parallel in, serial out, shift registers. Next, coming to another topic, counters. So counter is a circuit which will count the number of clock pulses. So here we are having n bit counters, 2 bit, 4 bit, 8 bit, 16 bit, like number of counters are there. And counters are classified into 2 types, synchronous and asynchronous counters. In detail, you will learn in the syllabus. So flip-flops and counters. So there are 4, just now I mentioned there are 4 types of flip-flops: SR, JK, D and T flip-flop. And what are the counter applications? So counter applications are used in digital clocks, frequency counters, timers and control systems. And last unit deals with memories and PLDs. PLDs are programmable logic devices. So in this unit, topics are RAM, random access memory, read-only memory, and there are some techniques to find the error at the receiver, error detection and correction technique. In this, we are having Hamming code. Next, PLA, PAL comes under PLDs, programmable logic array and programmable array logic. And some more sequential programmable devices are there. So these are the memory classification. And this figure represents PLDs. Program of PAL, PLA and PROM is also there. Already I discussed now. PROM is also there. So you will design circuits using any one technique. And the importance is data storage. You will learn concepts of data storage, how to do fast processing, okay, then hardware programmability. So finally, the conclusion is digital electronics is foundation for modern computing systems, essential for hardware and embedded design, and it is important for future technologies. Without digital electronics, there is no VLSI, whatever we are calling nowadays, VLSI. So thank you.